Okay, so in this video we're going to go over, and this got cut off, but this is 6.1. So it's 6.1, and it is using similar polygons. So let's start reviewing this material for the final. If two polygons, so polygon means multi-sided figure, are similar, and the symbol for similar is this little tilde right here, then the ratio of the lengths of the two corresponding sides is called the scale factor. Okay, so then also, if two polygons are similar, then the ratio of their perimeter is also, of their two perimeters, is also the scale factor. Okay, we should do a little definition here. What else do we know about similar polygons? Okay, all of the angles are congruent, and all the sides of similar shapes are in proportion. Okay, so we're going to go over that now. So question 24 says, given the similarity statement below, list all pairs of congruent angles and then write the ratios of the corresponding sides in a statement of proportionality. Okay, so we'll change color. This is the similarity statement. Okay, so that is the similarity statement. So if I ask you for a similarity statement, this is what I mean. If you look at the similarity statement, you'll always get the next questions correct. So look at the similarity statement. Angle or triangle ABC is similar to triangle DEF. That means, in terms of all similar triangles, have congruent corresponding angles. So that means that angle A, which is the first listed in the similarity statement, is not congruent to, or not similar to rather, but exactly equal to angle D. Okay, then look at the next angle. Angle B, that's in the first triangle, is exactly equal to angle E, which is the second letter in the similarity statement for the second triangle. And angle C is exactly equal to angle F. So you can label this if you like. So if I give one hash mark to A, I would give one hash mark to D. If I gave 2 to B, I'd have to give 2 to E. If I gave 3 to C, I'd have to give 3 to F. Okay, so this is listing all pairs of congruent angles. Okay, that's what I've done here. Now I'm going to change color, and let's list the corresponding sides. Okay, so the side between the single and the double angle for the first triangle is AB. So here's AB. That's going to be proportional to DE. So you write it like this. Over here I'm going to write AB over DE. That's my proportion. Then use the next two letters. The next two letters are BC. BC is proportional to, the last two are EF. And then that's proportional to first, or last and first, last and first. This is your proportionality statement. That's this. Make sure you understand the difference. Notice here, I have angles that are equal to each other, whereas in this box right here, I have sides that are in proportion to each other, so the fraction of one triangle to the other triangle with its corresponding parts, that ratio is all equal. The ratio is what gets me the scale factor. Okay, very important. Okay, so that makes us now move on to question number 25. So I'm going to change my color, and it says, well, actually, let me change that too. Okay, 25 says, determine if the triangles below are similar. So if so, write the similarity statement and determine the scale factor. So I have 3 ways to prove things are similar. Side, 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 angle, side, and angle, angle, similarity. Okay, so right now, I think I can prove it by all 3. This angle equals this angle, and this angle equals that angle. Once I observe that, I have proven by angle, angle that I have similarity. Okay, so then, what else could I prove? I can prove, let's see, look at the proportions between the sides. Is it true? So is this true? Is 3:6 just like, so I'm going to put a question mark, just like 5, which is the hypotenuse, is to 10, just like, question mark, 4 is to 8. Well, if you reduce them or do their decimal equivalents, you'll find that they all equal either 1/2 or decimal equivalents, they all equal 0.5. Since they are in proportion, I have now proven by side, side, side that I have a similarity between these 2 shapes. I can also do side, angle, side similarity. So the sides are in proportion. So let's see how I want to do that. Why don't I say 5 is to 10, just like 4 is to 8. Those are these 2 sides, and the angle in between with the 2 hash marks are both equal. So I have now proven by side, angle, side. Okay, so I've proven every which way that these 2 shapes are indeed similar. So can you now write the similarity statement and then determine the scale factor? So let me do a little bit of erasing so I can do that. So I'm going to pause the video. Okay, so we need a similarity statement. So if you start at the right angle, A, and then the right angle for the other triangle is F, the next angle we're going to go to is the one with the single hash mark. So that's B. The one with the single hash mark in the second triangle is D. And then the remaining angle is C in the first triangle and E in the second triangle. That's my similarity statement. Okay, and you can put a little triangle here if you wish and a little triangle there. But that's my similarity statement. So then can I also determine the scale factor? Well, all of these are in the same proportion. So here, 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 the same ratio. You want to get the scale factor to be in the reduced form, and 3/6, 5/10, and 4/8 all reduced to 1/2. And so 1/2 is the scale factor. Now in this situation, I am doing this triangle is to this triangle. So that's the similarity. So the small goes first, the small value goes in the top, the big goes second, and the big factor goes on the bottom. So the scale factor is 1/2, and the similarity statement is written here. Okay, so that completes, I believe, 6-1. Yes, and we skipped 6-2, so the next video we'll do 6-3 and 6-4.